we're gonna start today talking about the acceleration. These are the points that we're gonna discuss today. Okay, as you can see, we're gonna discuss what does it mean, the acceleration, motion with a constant acceleration, the speed time graph with a constant acceleration, and finally the motion in 2 dimensions. Examples, circular motion and the projectile motion. Okay, these are the points that we're gonna cover today. And these are some of the vocabularies that you might need, what I think that you might need. Let us start with the first point. What is the acceleration? The acceleration simply means the rate of a change, of the velocity. شباب, the word rate simply means anything. Rate anything that is divided by the time is called rate. So the rate is anything divided by the time. So if we divide the change in the velocity by the time, that would be acted as acceleration. Again, let me clarify it again. So the acceleration, according to the definition in a mathematical formula, these words, text, in a mathematical formula, I would say that A, the acceleration, equal the change in the velocity with time. The change in the velocity will be delta V, and the change in the time will be delta T. Okay. The units of the acceleration, in this case would be meter per second square. Remember, shabab, it's delta V. What does it mean? It means simply it's V final minus V initial divided by the time it takes between the final and the initial velocities. Okay. One more thing, shabab. The acceleration is a vector quantity for sure, because again, A equal delta V over delta T. The velocity is a vector quantity, so the acceleration is a vector quantity as well. What does it mean for us? When we say something is vector, it means something very specific. And the vector has a direction. It could be plus, it could be minus, depending on the direction of the vector itself. If the acceleration vector would be like that, it will be plus. If it would be like that, it will be minus, and so on. طيب. One more thing. Shabab, let me remind you with the velocity. Remember in the last lecture we said that the velocity depends on the speed and the direction. Any one of these two things, the speed alone or the direction alone, or both of them, will change, that will lead to a change in the velocity, right? And any change in the velocity will lead to an acceleration. So the acceleration also depends on the speed and the direction. So based on this simple argument, now let us assume that this car now, this object now is accelerating, it has an acceleration. Any object that will be having an acceleration A, it could be having one of two cases. It could be speeding up or slowing down, accelerating or decelerating. Slowing down, decreasing the speed, and the speed will decrease. This is called decelerating. Both are acceleration. Okay? طيب. My question is, how can we know that the object is going to accelerate or decelerate? If I told you that the acceleration direction, the acceleration is plus, does it mean necessarily that this object now that has A plus is going to accelerate? Hashbab? No. To be able to know if the object is going to speed up or slow down, you need two things, not one. You need the sign of the acceleration, is it positive or negative, and also the sign of the velocity, is positive or negative. Type. If I have both of them, how to decide if the object is going to speed up or slow down? If A and V are in the same direction, have the same sign. If both are positive, for example, or both are negative, the acceleration is positive and the velocity is positive, or the acceleration is negative and the velocity is negative, in both cases the object is going to speed up, will gain speed more and more. When the sign of the acceleration and the sign of the velocity are the same, like this case, look at that. The car moves to the right, so V is plus, and the acceleration is to the right, so it's a plus as well. plus and plus speeding up. طيب what if the car is moving backwards? V is minus. طيب where is the direction of the velocity? The acceleration is to the left. يعني if the acceleration is to the left will be negative as well. Negative and negative. Also the object is going to speed up. When the sign of the acceleration and the sign of the velocity are the same, the object is going to speed up, increasing in the speed. The second case of course اللي هي slowing down, يعني losing the speed. How that could happen? What is the condition? The condition will be طبعا of course the opposite to the first one. That will happen if the acceleration and the velocity has different signs, different directions. يعني if, like in this case, the velocity is plus because the object is moving to the right, while the acceleration is negative, as you can see. Since the signs are not the same, they are opposite to each other, in this case the object is going to slow down. Or the other way around, the car moves to the left, V is negative, and the acceleration is to the right, will be plus. In this case also, the object is going to slow down. I will summarize all of these cases. Look at this table, you will have all the cases. Speeding up means A plus V plus or A minus V minus. Slowing down يعني A plus V minus or A minus V plus. طيب. Now let us calculate the velocity. يبقى in the previous steps يا شباب we have defined the velocity, the acceleration. We knew now exactly what does it mean. What is the formula that we can use to calculate the equation and to calculate the acceleration and so on. طيب, how can we find the acceleration as a value? It depends on the problem. Some of the problems will provide you with some values. Like this one, look at that. I'm just telling you that we have an object, this airplane, that starts at rest. Starts at rest, that means that V initial equals 0. I have to put a شباب just on the problem itself. Put your values like that. That may things easier for you. And at the end of the runway, it reaches a speed of 80 meters per second. That of course should be V final. And that happens in 20 seconds, that would be T. How much is the acceleration? I should use this simple law, this simple equation. A equal V final, V initial, over the time it takes in between. It's clear that V final in this case is 80, V initial is 0, and the time is 20. So we have the acceleration is almost 4 meters per second square. Could we have the acceleration be negative? Of course. That could happen, of course, if V final is less than T. V initial, for example, an object that started the motion at 80 meters per second, and then it comes to rest. It comes to rest. Yani, V initial is 80, V final is 0. In this case, if you just find the acceleration, will be 0, the final, minus 80, divided by the time. In this case, yani if it is 20 as well, we will end up with negative 4 meters per second square. This is the first way to find the acceleration using the simple law A equal V final, V initial over the time. To be able to use this equation, we have to have, شباب, in the problem, we have to have this information. We have to have V final, V initial, and the time in between. That will be straightforward, okay? The second way to find the acceleration is from the graph. Yani I will just provide you with a graph between the velocity and the time, and I will ask you to find the acceleration from this graph. I think, yeah, Shabab, I think we have used something like that in the first lecture, if you remember, but it was between the distance and the time. Now the graph will be between V and T, the velocity and the time. And we will have, this is the 0, شباب, خلاص, and this is plus, and this is minus, because we have velocity. Velocity could be plus, could be minus, could be a vector quantity, okay? If I say, شباب, if you have here the speed, of course, if we have the speed here, we don't have any negative, okay? Because it's a speed, right? It should be having plus plus. But normally, we have the velocity, the time, this is the 0, and that will be plus, and that will be minus. طيب. And we will be having straight lines like that. طيب. This straight line يا شباب between V and T, of course it has a kind of slope, right? What the slope will represent here يا شباب? Yes, Nawaf, go ahead. Go ahead, Nawaf.
Slope is distance over.
This is not the distance. This is the velocity.
Okay, displacement.
Displacement?
Over time.
Is that the displacement? This is the velocity. طيب. Rashid?
It is the acceleration.
Why it's the acceleration? Why that slope is the acceleration in this case, Rashid?
Because it's speed over time. Speed over time is acceleration.
Oh, that's wrong as well. طيب يا شباب. Did I define the acceleration to be the speed over time? Did I say it something like that? Speed over time. Is that right? This is wrong.
No, it's the difference of speed.
The difference in the velocities, not the speed.
إيه.
Okay يا شباب? The velocities. يعني لو في speed يعني I would agree if we have, but anyway the right definition for the acceleration is the difference in the velocity. Yes, the slope means delta y over delta x, right? Delta y here يا شباب is represented by v, so it will be delta v over delta t. We have just defined what does it mean now. We said that's a equal delta v over delta t. That would be the acceleration. So if we have a slope line, a straight line here, the slope of this line will give us the acceleration. طيب, is the slope of this line is plus or minus? This slope now.
Plus.
Of course يا شباب. Any line in the first quarter or the fourth quarter, so if the line is here like that, will be the slope will be plus, or even it's there, also the slope will be plus. طيب, let's talk about something else. What about this line يا شباب? What about this line, this flat line? How much is the slope? How much is the slope of this line? Zero. So the acceleration also is zero. What does it mean? The acceleration is zero. The object is moving with a constant velocity. What about this line? Look at that one, شباب. This line also has a slope, of course يعني. And this slope يا شباب, what do you think? This slope is plus or minus?
Minus.
That's right. So what about this one يا شباب? In this quarter, ربع will be also minus. Okay, so that will be plus here or there, that will be minus here or there. طيب, that's good. Let me ask you something else. Remember شباب, this is V and this is T. Okay, طيب. Here in this line شباب, in this line the object طبعا, of course the object seems to accelerating, صح? Speeding up, because the speed is increasing, as you can see, right? Here we have zero acceleration, constant velocity, and then we have deceleration, يعني slowing down, right? Is that clear يا شباب? Is that clear?
Yeah.
Yes.
طيب. Can anyone tell me, if I'm talking now just about the values of v, the velocity on this line, all of them positive or negative? What do you think يا شباب?
Positive.
طيب. What about the values? What about the values of v here? V. I'm talking about v. Is it positive or negative?
Negative. Positive.
Of course, it should be positive.
Negative.
And negative there, it looks like it's going down. It's not going down. Yeah, شباب. This is the zero. All the values in this quarter is positive. So v is plus here, and plus there, and plus there. So where the velocity will be negative, if the line is something like that. In this quarter, the velocity is negative. Here, there, or there. All the values. This is the negative, شباب. This is negative side. So this is the positive side. So any value in this part will be plus. طب, let us apply this بقى. This is the two. يعني we have some problems. يعني let us apply our understanding. And did we understand it in a good way or not? يا شباب. We have this graph between the speed. Look at that شباب. When we have the speed, we don't have the negative, right? شوف, there is no negative here because we just the speed. Speed is a positive, right? But if we have v, we should have plus and minus. Anyway, all the values now in the plus, and we have 4 stages: stage number 1, stage number 2, stage number 3, stage number 4. Okay, and the question is, what is the acceleration? We have 4 accelerations. Where exactly is asking about? L of the object as it is slowing down. يعني we have to choose the part of the graph where the object is slowing down. يا شباب, what do you think? Is it 1, 2, 3, 4?
I can answer.
Who is it? Muhammad? Muhammad?
Yeah, doctor.
Yes. Go ahead, Muhammad.
Acceleration number 2, doctor.
Yes, in part number 2, right? Why? Why,
Yeah.
Muhammad? Why? Why it's slowing down?
Because in the second 2, the speed is 10.
The speed is
and,
the speed is decreasing. That's right.
Yeah.
The speed is decreasing. That's right. That's fantastic, Muhammad. That's that. Of course, you can see that, شباب. On this line, as you go down, what about the value of the speed? It's decreasing, صح? ما هو decreasing and slow down. This is one of that. That's right. That's right. So this is the only way or the only part of the graph in which the object is slowing down. I agree about that. I agree about that. That's right. طيب. Since this is the part, شباب, this is the part that the object is slowing down. Can we get easily the value of the acceleration? You would say that, of course, yes. خلاص, we know that the acceleration is the slope. Yeah, and you can choose any 2 points, like for example this point and that point. Then you can just calculate them, and you will end up with, as we expected, it should be negative in this case. The slope of this line is negative, so it's negative 2 meters per second square. طيب, what about this part يا شباب? Can anyone describe the motion of the object at this part, how it moves? عبد الرحمن.
Yes, the object move with the constant speed.
That's right. Again, I agree about that. And also in this part, it's moving with a constant speed. What about this part, شباب? The last part. محمد الملايو.
Doctor. The object is acceleration, speed on.
That's fantastic. The object is speeding up in this part. Is speeding up, gaining speed. As you can see, that's so simple, شباب. Right? Yeah, and we have this second problem. I'm not sure if we have time for it or not, but I will just skip it now. Inshallah, maybe at the end of the lecture, if you have some time, we can solve it again. It's almost, it has some concepts. And now we have come to the main part of the lecture, okay? That will be a little bit tricky, It's about two-dimensional motion. So what is the story behind two-dimensional motion? What do you mean by that, Shabab? I will tell you. Up till now, Shabab, if you just notice what we were doing in the first and the second lecture, we were just discussing or describing the motion of an object in one dimension. The object is moving in one dimension. For example, the object is moving only in the x direction. So there is no y component. Y component equals 0. ملوش مركبة في الواي, is only moving on the x axis. Or an object that moves in the y direction, north south مثلا, for example, okay? So it has only y component and there is no x component at all. ملوش أي مركبة في الx. This is what we call motion in one dimension. The object is moving on the x only or on the y only. And this is not real, to be honest with you. In the real situation, the object, at least any object, is moving in two dimensions. So we're gonna discuss this motion, but the real motion, okay? When an object that moves in two dimensions, طبعا it will be a little bit more difficult than one dimension. But the good news is, even if the object is moving in two dimensions like that, شباب, look at that. Here an object moves in one direction, an object that moves in one direction. Here بقى, in this line, the object is moving in two dimensions. This is the meaning of two dimensions. Look at that. An object that moves through this line is moving already on two dimensions. ليه? Because he has a component in the x and has a component in the y. As he moves, يا شباب, in this line, the x is increasing and the y is increasing as well. So he has two components. The x component increases and the y component. This is why we call it as two-dimensional. Okay, but again, the good news is that the vertical direction, this is the y vertical, العمود the vertical direction and the horizontal direction are totally, we're gonna deal with them mathematically as if they are totally independent. يعني what would happen on the x-axis will not affect on the y-axis. They are totally independent. That makes the mathematical treatment of any problem much easier. I will show you. طب let us have some examples of real motion. يعني that's an object that moves in 2 dimensions. This is one of them. It's the circular motion. One of the most famous types of motion in physics. An object that moves in a circle. Okay? Is it 2 dimension? Of course it's 2 dimension. The object now is moving in the x and the y at the same time. Yes. Look at that. If we just put our axes هنا شباب, our axes. This is the x and this is the y, and we have the object now here شباب. The object now here, it means that he is moving. Now he is increasing the y and the x at the same time, or increasing the y, decreasing the x. At the end of the day, he has a component in the x and a component in the y. This is totally 2-dimensional motion. Type. Circular motion is a 2-dimensional motion. What else? We need to discuss something else. This type شباب, if I told you now this horse شباب, this horse now moving this circular track with a constant speed. Concentrate please. Can I say that this object may have an acceleration or not? يا شباب, does it have any acceleration or not? طيب, let us take one of these guys. طيب فهد, do you have an answer يا فهد? Yes.
Of course, there is acceleration.
There's an acceleration. Even if the object is moving with a constant speed, we have an acceleration. How it could be?
Yeah, because there is a continuous change of direction.
سلام عليك يا فهد. سلام عليك. الله يفتح عليك. Let me just record your name. I like this answer شباب. This answer which is so straightforward, so simple as well. فهد. كيف جزاكم الله خيرا. So فهد يا شباب, فهد just told me right now that he said that of course he has an acceleration. It's true that the speed is constant, but he is continuously changing his direction. Remember, when the direction changes, the velocity will change. When we have a change in the velocity, we have an acceleration. This is the definition of the acceleration. تاني يا شباب, acceleration means change of the velocity with time. Now the velocity changes, so we have an acceleration. But this acceleration is a very special type of acceleration in physics. This is called the centripetal acceleration. The acceleration of an object that moves in a circular track is called centripetal. I think you know what this means now. We have the translation. Centripetal acceleration. And it is called centripetal شباب simply because we are moving on a circle. And in this circle we have always, in a circle has a center, right? It has a center. And the acceleration, the direction, remember acceleration is a vector quantity, okay? So it should have a direction. The direction of the acceleration شباب, of the centripetal acceleration is always pointing to the center. يعني if I ask any one of you now, where is the direction of the acceleration of this object now? I'm talking about this one. You will say easily, yeah, that's so easy. It should be downward because this is the center. طيب, where is the direction of the acceleration of the object in this position? Well, it should be so simple as well. It's to the east. What about this one? To the west. What about this one? Here. What about this one? There and there and there. So all of these arrows now representing the acceleration direction. Of course, it will be changing according to the position, but in any one of these positions, you can easily know what is the direction of the acceleration easily, because it will just refer or point to the center of the circle. This is why it is called centripetal, from the word centria. Right. The second, and this is the last point in the lecture today. What if we have a projectile motion شباب? المقذوف. Is the projectile motion is 2-dimensional? Of course, it's 2-dimensional. I will show you now why it's 2-dimensional motion. But look at this person now. He is trying to throw this ball. Okay, he tried to throw it horizontal, for example. He tried to throw it horizontal, but is it going to move horizontal all the way through? لا. Look at that, شباب. I have this pole now. I'm going to throw it exactly horizontal. خلاص? Just trying to do that يعني. طيب. This pole now will be moving according to this pushing force يعني. In one of these paths, we have possibilities. This ball might move exactly horizontal. This is one of the possibility. Or it could just fall down directly. This is another possibility. Or it shouldn't be this or that. It will take something in between. It will have this curve. ها شباب, what do you prefer? Any one of you, yeah, any one of you. Just take the mic. The curve, right? This,
Yeah.
I know you have studied that before. This is the projectiles. That's right. It should take this curve, and it should have this path. It will move like that in a curve. And my question is why? But first of all, شباب, while this object now, let us assume that this is the x direction and this is the y direction. The ball, شباب, the ball here, is it one dimension or two dimension? Is it moving now in one dimension or two dimension?
Two
Two
dimensions.
dimensions. Why?
Two.
Why? تقول لي والله easily. Yes, it has two components اللي هي مركبتين. One in the y, I would say that it has a velocity component in the y and a velocity component in the x. Right? It moves in the x and the y at the same time. This is why it's a two-dimensional motion. Okay? But remember, what's happening in the x will not affect what's happening in the y. They are totally independent. Keep that in mind. That makes things much easier. خلاص شباب؟
Okay.
طيب. My question, but why the ball is being moving in this curve? Why it moves in the curve? What makes it move? Why it shouldn't move? Yeah, I just throw it in the horizontal. Why it moves downward like that?
The gravity affected.
Yes, of course, because we have the gravity شباب. طبعا we assuming يا شباب now, from now on يعني, we assume that there is no air resistance. There is no air resistance. Make things a little bit easier يعني. So there is no air resistance يعني, there is no force in the x direction. The only force that will affect on the ball is the force of the gravity. And the gravity is always trying to pull things down. صح يا شباب? Gravity is always trying.
Yes, yes.
So this pole now will fall in a dilemma, in a problem. It would like to move forward because it has been pushed forward, but the gravity tried to pull it downward. So it will move in both cases, or in both directions. It will move forward and downward at the same time. That makes it move in a curve. This is the only way it will fulfill moving forward and downward at the same time, to move in a curve like that. Shabab, did we understand that why it moved now in the curve? Because of the gravity.
Yes.
The ball tried to
Yeah,
move
yeah.
because you push it in the x direction, so it will try to move in the x. It will try to obey you, right? But at the same time, there is another factor, which is the gravity that tried to pull it downward. So the ball will try to fulfill in between. خلاص? It will try to move forward and downward at the same time. That makes it move in a curve. طيب, I have a question, another question. This is the last one. And it will be very funny and surprisingly as well. شباب, now we have two balls. Ball number one, ball number two, okay? This is the ground. We have some distance D هنا ولا حاجة, okay? And we're gonna fire both of them, okay? At the same time, from the same height. At the same time, from the same height. Such that ball two will just let to fall downward directly. يعني ball 2 has only one component of the speed, Vy. It doesn't have any Vx because it's just moving the y direction. There is no x. While ball 1 will be fired horizontally. طبعا, of course, it will not move as we just discussed now. It will not move in the x direction. It will move something in between the xy curve, right?
Yeah.
So ball 1 now will have two components, Vx and Vy, okay? So that ball has two components and this one has just one component. My question is, assume that there is no air resistance. There is no air resistance. يعني we are in a free fall. We are in a free fall. You know what does it mean? Free fall. يعني the only force that apply on the objects is the gravity. The gravity is pulling them with the same acceleration, even if they have different masses. Keep that. Inshallah, we'll discuss the free fall maybe after 2 lectures. طيب, my question is about the times now. T1 and T2. What's the T1 and the T2? يعني after some time of course T1 ball 1 and ball 2 will hit the ground. طيب are they going to hit the ground at the same time يعني T1 equal T2, or they will hit the ground with different times? If they are different, which one will hit the ground first? What do you think, Ishbal? This is my question. It's me?
Same.
Yes.
Yes, can I
They will be arrive in the same time.
Why?
Because the Vx it doesn't affect the Vy.
Yeah, that's
It's me like it's the component in the X didn't affect the component in the Y.
that's fantastic. That's right. So what about the Y? Why they will hit the ground at the same time?
Because they have the same gravity. It's 9.8.
Great يا عبد الرحمن. Great. That's the point يا شباب. That's the point. Look at that. شباب. We have pole 1 and pole 2 both fire at the same time. صحيح يعني it's right that pole 1 will move a further distance in the X direction, but if you remember X will not affect on the Y. Now I'm talking about which one will hit the ground first, so I'm talking about the vertical direction. طيب let us talk about the vertical direction. We have Vy here and Vy there. Are they the same? Yes, they are the same. Why they are the same? Because we said at the beginning there is no resistance. So both of these two balls will be affected only by the gravity, and the gravity will pull. Both of them are the same gravity. So both 1 and 2 will move downward with the same acceleration, 9.8. The same acceleration means the same speed. So Vy here equal Vy there. The velocity is the same. So now the velocity is the same. I'm talking about the vertical, شباب, the vertical. The vertical velocity of both of them is the same. And they start at the same time and they will move the same distance. Same velocity, same distance. What we're going to have in this case? Same time, right? Is that clear, شباب? Same velocity in the y direction, same distance they will travel, same velocity, same distance. Of course, they will hit the ground, they will reach the ground at the same time. طيب, I have one point here, شباب. Does it mean that they have the same overall velocity? No, of course not. They don't have the overall. This is one of the things that makes things might be confused here. Okay? I didn't say that ball 1 and 2 have the same overall velocity. لا, that's wrong. Vy and Vx. If we are going to talk about which one is faster a little bit as an overall, of course that will be a little bit faster because it has one more component. يعني the resultant velocity here يا شباب is bigger than the resultant velocity there. المحصلة يعني. Okay? But this will not affect on the vertical direction. Now we are talking about the vertical direction. In terms of the vertical direction, they have the same vertical speed. Now, in terms of the overall velocity, طبعا of course, pole 1 is a little bit faster than pole 2.